Heat transfer, okay. Basically, you have a high temperature fluid, okay. Essentially, it's convection and conduction. It's all included in one, and that's what this thing. Remember, we talked about this value U, overall effective heat transfer coefficient. We had them in with our buildings. Remember, we had the windows, doors, and walls, and all that kind of stuff in there for you HVAC people. And but really, so in other words, so we're not worried about the what splitting the two out, but that's basically what it is convection and conduction. And really, for the most part, we're not including because it's, remember, like that problem we did on the insulation. If you look at the thickness of the pipe itself, typically with insulation problems, we neglect the thermal resistance. Um, Excuse me. Oh boy, I need that drink. It's not alcoholic. It's just soda pop. Um, I don't think I could teach having a buzz, but anyway. Um, so in other words, so in other words, what you're not seeing, you really don't get into the because really the biggest resistance is going to be from the fluid flows themselves and that type of thing. All right. So you basically, for the exam, going to have two different types. You're going to have a parallel flow and a counterflow heat exchanger. And I'll show some pictures on that, and you'll be able to discern that quite readily. In fact, we got a really nice problem in the workshop that we'll end up doing. I don't know how far we'll get tonight. If not, we'll finish it up on Monday, 7 o'clock New York time. Basically, counterflow heat exchanger remove more heat, okay, than parallel. Then have and basically they have a very high temperature difference across the entire heat transfer length. Parallel flows have a large temperature difference at the inlet and essentially a smaller temperature outlet at the outlet. And there's different applications. It depending upon the material. Like for instance, in wastewater treatment plants, we have a lot of stuff that they call sludge, and typically what you end up doing is cooling, heating it up or cooling. Well, it depends. Typically, what we're doing is basically going to heat it up. So there's certain applications over the years, but we're not going to worry. We're just going to worry about the flow. Typically, what you're going to see on the exam, you're not going to have sludge in there on the exam, but different applications require counterflow or parallel flow. Okay, so just know that what they are. The heat transfer rate, and this tends to cause a little consternation over the years, because all right, what you have is this is for a heat transfer for a heat exchanger. All right, we're talking about M dot. Remember we talked about M dot. Let me see if I can do this. M dot C sub P. Okay, sorry, delta T. Okay, and we're going to see that a lot. That's essentially the heat transfer of the hot fluid and the cold fluid. M dot C sub P delta T. Okay, and you got the hot fluid and the cold fluid going on in there. Right, and it's pretty obvious. Okay, what's the hot fluid and the cold fluid, which becomes very important when we talk about the NTU method because it's not that obvious. It's not just the temperature. It has to do, well, I'll describe that a little bit when we get. Well, I'll get into it when we do the NTU method. In the NTU method, which is the hotter fluid, and that's the function of the mass flow rate and the overall C sub P, and we'll see that when we get into that section. But for this, all right, so you get the M dot C sub P delta T, the hot fluid and the cold fluid. All right, and typically you have your temperatures, so you know what they are. Okay, so once you get that, so that's where this Q is. Okay, so the cold fluid is picking up the um, the heat from the hot fluid. All right, and you can calculate that Q value, Q dot from either working fluid. All right. And typically, what you're going to find is that you're either going to be calculating area, and sometimes you calculate the area. They want to know basically how what's the total length of pipe that you have to put in there. Okay, as an aside, I think I have one in the if I remember right. I think there's one in the workshop. But basically, what you're looking at here is the area of the heat exchanger, overall heat transfer coefficient, and this is typically given, or they may ask you to calculate it, but it's typically given in a problem statement. But this is the key takeaway here is that log mean temperature.